All right, day 2 of heating Earth. Because we're on a short week, we've done an extra half of a set, or an extra one page. So now we are on page 197, comparing Earth and the Moon. As you have seen, Earth's atmosphere helps moderate the warming effects of the sun. What would Earth's temperatures be like without its atmosphere? For a useful comparison, consider the Moon. Okay, so comparing Earth and the Moon. Comparing Earth and the Moon. Earth atmosphere moderates temperature, arrow steady. Okay, so we were talking about temperature. We were talking about moderate. Right? Moderates temperature, arrow steady. The Moon is the same distance from the Sun as Earth, and it receives the same amount of solar energy per square meter. Yet with essentially no atmosphere, the Moon's surface temperatures vary dramatically. So, Moon is close to Earth, indent, but no atmosphere. During the day, the Moon's surface absorbs most of the incoming solar radiation, so the surface is extremely hot. At night, the Moon's warmed surface emits infrared radiation that escapes easily into space. The surface becomes very, very cold. So, day equals extremely hot, exclamation point. Night equals very, very cold, ... Another difference between Earth and the Moon is the way the daylight sky looks. Why is Earth's sky blue while the Moon's sky is black? Once again, the explanation is atmosphere. So, Earth, blue light scatters equals blue. Moon, no scatter equals black. Sunlight entering Earth's atmosphere scatters or bounces off molecules in the air. Light at the blue end of the spectrum is scattered more effectively than other colors. As a result, more blue light is scattered toward Earth's surface and the sky appears blue. So, all this light comes in. Some of it gets absorbed by the surface, warming up the surface of the Earth. It radiates back out to space, but the atmosphere captures some of that heat and keeps it here, keeps things warm during the night. And then that light coming in gets scattered by the atmosphere, and we see all of the blue light scattering. The rest of the light bounces off the surface of the Earth and goes back out. As a result, more blue light is scattered toward Earth's surface and the sky appears blue. Because the Moon has no atmosphere, no molecules scatter incoming sunlight. The sky takes on the blackness of space. So that's why we put blue light scatters for Earth equals blue, and for the Moon we put no scatter equals black. Study the two photos closely. What other differences do you observe between Earth and its Moon? Okay, so I made a little chart. Earth on the left and Moon on the right. Earth has water, but the Moon is dry. Earth has landforms, but the Moon seems flat. Right? You have rivers, you have mountains, hills. Here, it just looks flat. The Earth has life, but the Moon is just rocky. Life, just rocks. The Earth has a lot of color, but the Moon is just gray. Color, gray. All right, if you notice any others, put them in the columns that they belong in. Okay, why do temperatures on Earth and the Moon differ so greatly? Temperatures on Earth and the Moon differ so greatly because the Earth has an atmosphere and the Moon does not. The Earth's atmosphere helps moderate temperatures, making them more steady. In the day, it's able to capture some of the heat, and then at night, it uses that infrared heat to keep the Earth warm. The Moon gets extremely hot during the day because there's no atmosphere to block some of that energy. And then at night, it gets very, very cold because there's no atmosphere to hold on to that heat. It all escapes out into space. Okay, now, because the Moon has no atmosphere, temperatures there vary greatly. Daytime temperatures reach 130 degrees Celsius or 266 degrees Fahrenheit. Since we deal with Fahrenheit, I put that 266 degrees Fahrenheit. That's like hotter than boiling water. At night, the temperature plunges to minus 173 degrees Celsius or negative 279 degrees Fahrenheit. Negative 279 degrees Fahrenheit. That is way colder than freezing. Freezing is only minus 32 degrees Fahrenheit. Okay. Any other information? Earth's atmosphere keeps surface temperatures in a moderate range, allowing water to stay liquid. So, finishing up to compare the Earth and the Moon, the atmosphere moderates things, keeping the temperature steady. That helps there be life and water. Okay, the next page, 198. The greenhouse effect. Greenhouse effect. Have you ever been inside a greenhouse? You may have noticed that the air inside a greenhouse is warmer than the air outside. A greenhouse works because it traps some of the sun's energy inside. In a greenhouse, radiation from the sun enters through clear glass panels and warms the surfaces inside. The warmed surfaces radiate energy back in the form of infrared radiation. However, the glass panels do not let much of the infrared radiation pass through. The energy is trapped inside. So, like in this picture shows, you get light and energy getting into the glass, inside the greenhouse. It warms up all that air inside the greenhouse, but then that heat doesn't get back out. It stays inside. So the greenhouse is warmer than the air outside around it. Okay, inside glass equals warmer, traps energy. Parentheses, capital I, capital R for infrared. Okay, greenhouse gases, squiggle, glass. The greenhouse gases act like glass in the Earth. Those greenhouse gases absorb radiation and they prevent it from escaping. This mechanism for warming the surface and lower atmosphere of a planet is known as the greenhouse effect. Without an atmosphere to create a greenhouse effect, life on Earth would be impossible. As you learned earlier, places with little or no atmosphere, such as the Moon, experience very large temperature changes from day to night. Okay, so some greenhouse effect needed for life. Steady. Capital G, capital E is greenhouse effect. So we need a little bit of the greenhouse effect to have life on our planet. It keeps temperatures steady. Let's put next to steady, let's put steady temp, capital T-E-M-P, period. All right, now we're on page 199. The greenhouse effect depends on certain gases, called greenhouse gases, that occur naturally in the atmosphere. These gases include water vapor, methane, nitrous oxide, and especially carbon dioxide. The greater their amounts, the more solar energy is trapped, and the warmer the atmosphere and surface become. Okay, so examples: water vapor, zoop; methane, zoop; capital C, capital O, and a number 2 down low. That's carbon dioxide. Exclamation points, because as we now all know, carbon dioxide is a very important gas for greenhouse gases, for climate change, and for global warming. When we breathe in oxygen, we breathe out carbon dioxide. When we burn gas in a car, or we burn fuels to heat our house, like natural gas, or we burn coal to generate electricity, CO2 is all getting pumped out into the air. We are creating more and more CO2 than what is normal, and that's why things are getting warmer. That's why it's called global warming. Okay. How important are greenhouse gases? To find the answer, compare Earth with its 2 neighbors in space, Venus and Mars. All 3 are rocky planets, but each has a very different atmosphere. Okay, so if you want to figure out what's going on, find your closest neighbors, the ones that are just like you, the same kind of rocky planets, find out what's happening on them. Venus has a very thick atmosphere. See how it's very thick looking compared to Mars's very thin atmosphere? The atmospheric pressure on Venus's surface is about 90 times that of Earth. In other words, it's 90 times as thick, 90 times more atmosphere, very thick. And unlike Earth, the atmosphere of Venus consists mainly of carbon dioxide, almost 1,000,000 times the amount in Earth's atmosphere. Think about that for a second, 1,000,000 times as much CO2 in Venus. As a result, it traps most of the infrared radiation from Venus's surface. The average temperature on Venus is about 480 degrees Celsius, 900 degrees Fahrenheit. So remember we talked about how hot the moon was and we're already boiling water? 900 degrees for Venus. That could melt many types of metal. This is the highest surface temperature on any planet in the solar system. It is even higher than on Mercury, the planet closest to the Sun. So Mercury is closer than Venus to the Sun, but Venus is still hotter because of all this thick atmosphere trapping all that energy, all that infrared radiation inside. Okay, Venus equals thick CO2, arrow, hot, exclamation point, 900 degrees Fahrenheit. Like Venus, Mars also has an atmosphere that is mostly carbon dioxide. Yet, Mars has a very thin atmosphere. The pressure is about 1/100th that of Earth. So that's only 1%. On Mars, infrared radiation can easily escape into space. As a result, the surface temperature on Mars averages negative 65 degrees Celsius or negative 85 degrees Fahrenheit. So that's colder than the moon. I'm sorry, not colder than the moon, but colder than freezing water. Venus and Mars illustrate a lesson for anyone who cares about life on Earth. The lesson is that the right amount of gases in the atmosphere is important. Temperatures on Earth's surface depend on them. Okay, Mars equals thin atmo with a period, arrow, cold, ... negative 85 degrees Fahrenheit, just like they said here. Okay, Earth equals quote unquote just right. All right, Venus has a very thick atmosphere of carbon dioxide, creating a large greenhouse gas effect. The surface of Venus is extremely hot. Okay, we already have that. Mars has a very thin atmosphere, and the greenhouse effect is slight. Temperatures on Mars can be very low. We have that. How does Earth's atmosphere compare to those of Mars and Venus? Earth's atmosphere compares to Mars and Venus because it is different from both. Venus's atmosphere is much thicker than the Earth's and mostly CO2, so it traps a lot of energy and becomes very hot. Mars's atmosphere is much thinner, therefore allowing a lot of energy to escape back into space, making it very cold. Earth seems to have just the right amount of atmosphere to keep us warm so that we can have life. Okay, now you can see how all the human activities that generate CO2 and put more CO2 into the air than used to be are causing it to warm up and get warmer. Okay, I think that is it for today. Let's go ahead. Oh, let's look at this picture real quick. We have the sun and solar radiation coming in. We know that it warms up the surface of the Earth during the day. At night, we know that that warmth kind of radiates back off the surface. But because we have an atmosphere, the greenhouse gases absorb some of that radiation and keep that warmth here. So much of the energy is re-radiated back to Earth, keeping it a little bit warmer at night than it would be in Mars. Mars gets even colder because there's very little atmosphere. Venus has so much atmosphere that it's not allowing any energy to escape. It just keeps getting hotter and hotter and hotter and hotter, so hot that it gets all the way up to 900 degrees Fahrenheit, enough to melt some kind of metals. All right, good job persevering with a growth mindset, and roar Wildcats!